Yeah, get your mental up, guys, because it is Friday and we're doing notes number 4, which is factoring by grouping on today's episode of the fun-filled, action-packed, non-flipped Algebra 2 Classroom video. With me! Alright, so factoring by grouping. Types of factoring. So we've been factoring for a while now, and we've been doing a bunch of different types of factoring. Okay, one of the ways that we learned was factoring by GCF. That's where you don't even have to do the X box. All you do is take out the greatest common factor, and you can solve for your X right away. We did one of those examples yesterday where there's no X box needed. That's just factoring by GCF. So then, of course, the next way that we did is with the X box. Okay, and the X box we used to factor out trinomials. Trinomials are like ax squared plus bx plus c. That was the X box method. Then there was also a shortcut for certain types of problems, and that was the difference of squares. I remember difference of squares is when you have a squared minus b squared. That's the same thing as a plus b times a minus b. And then lastly, yesterday, we did sums and differences. Sum and difference of cubes. And that's when you had a cubed plus or minus b cubed. And now we're going to be doing a new type of factoring, which is called grouping. Grouping. Alright, so grouping is typically going to be used, to factor cubic polynomials with 4 terms. But it can also be used. To factor trinomials. Whoa. But for our purposes, we're going to be using it mostly to factor cubic polynomials with 4 terms. Now we're going to do the most basic example, guys. This is going to be showing you the steps of grouping with a simple example. That way you can follow these steps all the time and you'll be able to get your answer. So we're going to do an example. Factor x cubed plus 3x squared minus 4x minus 12. So how do you factor such an expression like this? It starts with cubic. You see it's x cubed, and there's 4 whole terms. So this is when we use grouping. So the first step is you're going to group the terms. And in our case, we're going to group them into 2 pairs. So how do we group them? We just put parentheses around our terms. So x cubed plus 3x squared. That's going to be my first group. So what do you think is going to be my second group?
Negative 4x minus 12.
Right, negative 4x minus 12. That's going to be my second group. So we separate them into 2 groups using parentheses. So group terms. The next step is now you see once we've grouped these terms, right? Each group has its own greatest common factor. So we're going to take the greatest common factor out of each group. So look at the first group, x cubed plus 3x squared. What is the greatest common factor right there?
X.
Just x? X squared. Right, both have x squared in them. So if I factor out the x squared, what's going to be remaining in my parentheses? X plus 3, that's right. Very good. All right, now what is the GCF in my second group? Negative 4, right. We want to factor out the negative when we can. So we factor out the negative 4, and what will be remaining? X plus 3, right. Now, a very convenient thing about factoring by grouping is that it kind of tells you if you're doing it right in the middle of the problem, because if you factor the wrong number out, your parentheses will have different results. You see how right now both of my parentheses say x plus 3, right? That's how you know that you've chose the right number to factor out. The parentheses need to be the exact same. Otherwise, this doesn't work. All right? So this step will factor out GCF of each group. Right, because notice if you had just chosen to factor out a positive 4, you would have negative x minus 3 in your parentheses, and that would not match up with your first set of parentheses. All right, so then from here, notice how each of these terms right here is being multiplied by x plus 3, right? There's an x plus 3 attached to each of these terms. So what we're going to do is factor out that x plus 3. We're going to factor the x plus 3 out of each of these terms, like this, x plus 3. And if I factor x plus 3 out of each of these terms, what's left? Right, just x squared minus 4. So then I'll only be left with x squared minus 4, which is going to be my other set of parentheses. So for this step, I'm going to write out factor out common binomial, which in this case was x plus 3. All right, it's not like one of the x plus 3's just disappeared, okay? Just like up here, where you factor out a negative 4, right? You took the negative 4 out of each of the terms. It's the same idea. You're taking the x plus 3 out of each of these terms. It just looks a little different because, x plus 3 has more than one number in it. But that's the same idea. All right, so then one final step here is notice x squared minus 4, that can be factored further, right? Because x squared is a perfect square, 4 is a perfect square. They're being subtracted, which means you can factor that out using the difference of squares shortcut. So do you remember, if I were trying to factor this out by difference of squares, what my factors would be?
X plus 2 and x minus 2.
Right, x plus 2 and x minus 2. Remember the shortcut is you take the square root of the first term, square root of x squared is x, right? That goes in each parentheses. What's the square root of 4? 2, so 2. And then 1 needs to be plus, 1 needs to be minus. And then also at the very front, we can't forget the x plus 3. And this is our completely factored out polynomial. So we factored out the difference of squares. And that would be the answer right there. X plus 3 times x plus 2 times x minus 2. And that's pretty much the steps for factoring by grouping. So we're going to do a couple of examples here to get some repetition and try to memorize the steps. So let's write down example number 1. We're going to put x cubed minus 5x squared minus 7x plus 35. All right, so using the example that we just did, right, let's try to guide me through the steps. What would my first step be? Group them how? Right, so I put the parentheses around my first two, and then I add my second group, which is negative 7x plus 35. Right, so I've grouped my terms. What do I do after I group my terms? Factor out the GCF. So what is the GCF in the first group? X squared, right. If I factor out x squared, what's left? X minus 5, that's right. Now what's the GCF in my second group? 7? Negative 7. Notice if I just factor out a 7, my parentheses are going to be different. So I factor out negative 7, what's going to be inside my parentheses? X minus 5. Because 35 divided by negative 7 is negative 5. And that's what you wanted. Right? Because the parentheses need to match up what's inside the parentheses. Okay, so now that I have taken out the GCF, what's my next step? Right, so what would it look like if I factored out the binomial? X minus 5 times x squared minus 7. Right, you factor out the x minus 5 from both of these. If I took the x minus 5 away from both of those terms, what's left? Just x squared minus 7. That's right. And from here, you check to see if you have a difference of squares. Okay, so do we have a difference of squares down here? Do you?
No.
Why not?
Because 7 doesn't.
Right, because 7 is not a perfect square. Now, if you wanted to, right, just so you could see what your answers were going to be, right here, technically you can stop here. Okay, this is factored as much as possible. But if you wanted to factor out even more, even though this is not a perfect square, you could write like this: x plus square root of 7 times x minus square root of 7, right? Square root of 7 is not a whole number, so you don't have to go this far. But if you did it like this, you can see very easily what your answers are going to be for x, you know?
So you can do that either or.
Either or, yeah, right. This way, if you go even further with the square root of 7, that's going to help you solve for x very quickly, you know? Because from here, it's obvious. The answer is negative square root of 7, positive square root of 7. But it's not absolutely necessary. Let's do one more example right here. X cubed plus 2x squared minus 5x minus 10. All right, what is the first step? Group them. How? Okay, that's one group. And then? Okay, so I've grouped my terms. What am I going to do after I group my terms? GCF. What is the GCF of the first group?
X squared.
X squared. So I factor out the x squared, and what is left on the inside?
X plus 2.
X plus 2. What comes next?
Negative 5.
Negative 5. Right, that's the GCF of the second group. And that would leave me with what inside?
X plus 2.
X plus 2. Yeah, so be careful, because look, negative 10, right? Divided by negative 5 is positive 2. If it was minus 2, then you'd have an issue, because the parentheses would not be the same. So what is next? X plus 2? Whoa.
X squared minus 5.
Right. He's getting it. When you take out the negative 5, right, you have to divide both of these terms by negative 5. So if you take negative 10 divided by negative 5, yeah, that's why it's positive 2. Okay, so yeah, you can stop right here. This could be your answer, but if let's say you wanted to take it a step further, what could you write if you wanted to take it a step further? Right, x plus 2? Right? That's right, very good. Very good. Okay, that would help you solve for x very easily, yeah. All right, so speaking of that, if I wanted to solve, what would I have to do? If I wanted to solve for x. Yeah, you set them equal to 0, that's right. And that's what we're going to do on these next two examples. So turn your page over. So example 3 is going to be x cubed. What? Wait a second. Where's it going? Wait a second. Okay, so write this one down. X cubed plus 3x squared minus 25x minus 75. So here are the instructions. It says solve by factoring. So make sure you understand what the instructions say. That's our biggest issue usually. Not the mathematical skills, but actually just understanding what we're doing. As in vocabulary questions. Okay, so what's the first step here? Group them. How are we going to group them?
X cubed plus x squared.
X cubed plus?
X squared.
3x squared. And then?
Negative 25x minus 7.
plus negative 25x minus 75. That's right. Okay, I found my groupings, and now what am I going to do after that? GCF, which is, what is my GCF in the first group? X squared, which leaves me with? X plus 3, right. What comes after that? What's it going to be? Negative 25. If I factor out negative 25, what am I going to have inside the parentheses? X plus 3. Very good. All right, now I've got my greatest common factors factored out. What comes next? Right, x plus 3 times x squared minus 25. Yes.
You see how the
Okay, so we got to this point. What do you do next? What should you check for here?
If it's squares.
Right, if it's perfect squares in this term back here. So, is it perfect squares? Yes, it is. So x squared minus 25 is perfect squares, which means what can we do with the x squared minus 25? X plus 5, right? You gotta take the square roots. And then? X minus 5, good. And then don't forget the x plus 3 at the beginning. So there we go. Here it is fully factored out. X plus 3 times x plus 5 times x minus 5. So remember, this question says to solve. So what else do I have to do after this? So how do I do that? What do I write? X plus 3 equals 0? Right, and? Okay, so then what are my x's equal to? Right? And there we go. Right, x equals negative 3, x equals negative 5, and x equals 5. Very good. We're going to do one last example for grouping then. All right, so this example is going to be x cubed minus 2x squared minus 9x plus 18. All righty. What are we going to do? Group them how?
x cubed minus 2x
Okay.
and negative 9x plus
So don't forget to write the plus sign in between your two groups. Right. Okay. We've grouped them. Now what? What is the greatest common factor in the first group? X squared. X minus 2. Very good.
negative 9
Negative 9. That's right. X what?
X plus minus
X minus 2. Both of them, yeah, both of them divide. And they both need to be the same. You can't assume they're the same because if they aren't the same, that's telling you that you did it wrong, right? So just divide that negative 9 out of each of those terms and that will tell you what you have. Could be. It's not really a trick. You just got to pay attention. You just got to, yeah. Got to just you work the problem, you know, see what you get. Don't assume. If you assume, you might mess up. All right, so anyways, we get to this point, and then what? X minus 2 times x squared minus 9. All right. What comes after this?
Isn't it perfect
X minus 2, and then what are we saying? Right? X minus 3, right. Because x squared minus 9 is a perfect squares, difference of squares. So you can factor it out to x plus 3 times x minus 3. We have to solve, so what do I do after this? Set them equal to 0. So what are my x's? Right. Right. And that's right. There we go. So x equals 2, x equals negative 3, and x equals positive 3. Very good. And that is it for grouping. So our last thing then is we've got a bunch of different ways of factoring, right? So I would separate my factoring into 3 different types. There is grouping, which we just did. Xbox, right? And then GCF, where you don't even have to use the Xbox. So in these next 6 examples, all I want you to do here is decide and write which method do you think is the best for each problem. Grouping, Xbox, or GCF. So take a moment and write what you think would be the best for each example. On example 5, what did you think the best way is on 5 is? Xbox, right? Because if you add 20x to both sides, then you'll see you have 7x squared plus 20x minus 3 equals 0. And then we have the A, B, and C, right? Which is Xbox. Okay. What about example 6? Grouping, right? And what was the? How did you know it was grouping? What gave you that idea? There's 4 terms and. And the first term is x cubed, right? That also gives it away when you have cubes. All right. What about example 7? Xbox. Greatest common factor, because look, if I add 2x squared to both sides, I get 2x squared plus 40x equals 0, and then all I have to do is factor out 2x, x plus 20, and look at this, right here, 2x times x plus 20, I could solve right there, right? There's no need for Xbox. This is the one that confuses you guys the most because you want to overcomplicate it, you know, but you could stop right there and just solve. Yes. Example 8. What would example 8 be? Grouping, right. All you have to do is subtract 48 to the left side, and then you'll see there's 4 terms, and it starts with x cubed, so that's a very big red flag for grouping. What about example 9? GCF. That's right, because if you subtract the 4x squared from both sides, that combines with the 6x squared over here, which gives you 2x squared minus 20x equals 0. And you can factor out 2x, which gives you x minus 10. And right there, GCF, I could get my answers right away. No need for Xbox. What about the last one? Xbox, right. If I add x squared to both sides, I get x squared plus 5x minus 6 equals 0. And then I see my A, my B, my C. That's Xbox. And that is going to be the end of these notes. So until next time, I'll see you next one. Peace.